name is Alicia Shapiro with AInews.com, and welcome to another episode of our Driving Tomorrow Conversations with Industry Leaders, where we explore the real world impact of artificial intelligence across industries. Today, I'm excited to be speaking with Jaime Lien, co founder and chief scientist at Archetype AI, a company pioneering physical AI and building technologies that help machines perceive, understand, and reason about the real world. Jaime brings a deep experience in perceptual sensing, radar, signal processing, and AI. Before co founding Archetype, she was lead inventor of Soli Radar at Google's Advanced Technology and Products Group, helping move the technology from concept to deployment in consumer products. And earlier in her career, she worked at NASA's Jet Propulsion Laboratory on wireless communication and localization systems for space missions. Today, Archetype AI is building Newton, a foundation model for the physical world that fuses real-time sensor data and natural language, helping people ask questions about what is happening across environments, systems, and assets. In today's conversation, we're going to be exploring what physical AI really means, why sensor and behavior data still matters, and what it takes to build AI for the real world, and how this technology could change industries from manufacturing and construction to cities, infrastructure, and everyday tools. So thank you for joining us today, Jaime.
Thanks so much for having me.
Oh, absolutely. I'm glad to have you here. So let's start with the big picture. Physical AI is getting a lot more attention right now with Fei Li and her World Labs company, but the term still feels abstract to a lot of people, and they mostly think robots. So,
Mhm.
from your perspective, what does physical AI really mean, and why is it becoming so important now?
Yeah, so to me, robotics is a subset of physical AI.
Mhm.
Physical AI in the bigger picture just means AI that is grounded in actual physical measurements and observations of the real world. So, unlike LLMs, for example, which are trained on digital artifacts like text, images that you might find on the internet, physical AI models are actually trained on sensor data. So, camera data is one modality, but there are a huge diversity of physical sensor modalities, different types of physical quantities that can be measured: gas, pressure, electricity, all these different meteorological parameters. And that wealth of information can actually go into helping AI to understand the way that the physical world works and then reveal those insights to humans.
That's really cool because as I was reading up on it, I was one of those people that thought, oh, it's just for robotics. But as I was reading up more on what Archetype does and what physical AI is, I was like, wow, this could really actually be useful for a bunch of different industries. And most people are familiar with AI that works with the text and images and like ChatGPT and Claude. But what makes the physical world such a hard environment for AI to understand?
Yeah, so fundamentally, the physical world is just completely dynamic. We use the term non-stationary in technical terms, and there's just an extreme diversity. If we think about it, like even machines that are of the same nominal type, the same asset type, they all actually differ in terms of their instantiation. So one drilling rig, even though it is the same nominal type as another drilling rig, actually has a lot of differences in the way that the hardware is configured, changes in the way that the machine degrades over time. They have different deployment areas, and the impact of the environment on the physical process will cause them to behave differently. As I mentioned, the general behavior of the machine is evolving due to wear and tear or degradation. And just overall, there's an enormous amount of diversity, both in the physical assets and processes themselves, but also the observation mechanisms, so the sensor modalities that we use to measure these processes. And so being able to generalize and scale across just this enormous diversity and keep up with the constant evolution of the physical world is a challenge that we don't have to the same scale when we work with digital assets like text and images.
Do you think part of what physical AI is in terms of city planning and infrastructure and things like that? I guess what used to happen even just a few years ago with surveying. I don't even know much about surveying, but I know they have these cameras set up and they're measuring different things for different planning of new construction or new buildings. Is that part of it, or and the AI is now getting involved?
That can definitely be one of the use cases.
Okay.
I would say one of the more predominant target industries that we've seen interest from is in areas like industrial manufacturing, for example, where different industries and different companies, they might operate tens to hundreds of different machines on a factory floor. And today, almost all of these machines are equipped with sensors that are continuously measuring their internal conditions, but also their environmental conditions, so external environmental factors. And fundamentally, the problem of turning all of these diverse streams of different physical measurements into some sort of actionable insight about what the system is actually doing, how it got into its current state, and what is going to happen next is this problem that is not new. People have been trying to solve this for a long time, and previous techniques in classical ML just hasn't been able to scale. But now, with the emergence of large models and large physical AI models, there's the promise that we can actually develop an approach and a paradigm and a foundation model that can actually generalize across these huge long tails of different sensors and different machines.
That's really cool. And one thing that stood out to me was that also seems central to physical AI is the physical world is constantly producing those signals, movement, sound, temperature, vibration, the location, patterns that people don't even notice as they're happening, probably. So when those signals are connected and they can show how systems and objects and environments are behaving, like you were talking about, what kinds of real world patterns are machines able to detect that humans might miss today?
Yeah, so I think there's different categories of things. One is just the modalities, the sensor modalities themselves might be able to capture phenomena that we as humans can't directly perceive. Electrical type of measurements are just one example. We can't directly feel the current running through a wire. We
Right.
can't directly see RF waves propagating through the environment. But with the use of these non-biological like sensors, now we have access to actually measure these things and with AI to interpret them into some meaningful insight about what is happening in the physical world. So I think the ability to capture this broad spectrum of different phenomena that aren't directly perceivable to humans is one aspect.
Mhm.
The other aspect is there are a lot of phenomena in which the scale is just either too enormous or too micro for humans to actually perceive. So we have a use case, for example, where we worked with the city of Bellevue in order to analyze pedestrian safety at traffic intersections and the ability of AI to basically combine together lots of sources of information, both from cameras, but also those traffic signals themselves, and then notice subtle patterns of when people step out into an intersection versus when they're staying back, basically enables our model to be able to recommend when unsafe situations might be about to occur, and then to basically affect a change in these traffic patterns in order to prevent that.
That would be very helpful, especially if certain cities have really dangerous intersections, and this would help improve the safety for everyone. Yeah. Archetype built Newton to fuse sensor data and natural language so people can ask questions about the physical world, like I mentioned in the introduction. But for people who are hearing about it for the first time, how does Newton work and what changes when teams can interact with real world systems this way?
Yeah. So Newton fundamentally combines a number of different core paradigms. We like to refer to our basic approach as locally adapted world models. World models because they understand what is happening and the behavior of the real world, and locally adapted because they can actually adjust based on local sensor observations to the particular physics and operating history and contextual information of each individual machine. So I mentioned before that there's this extreme diversity and constant evolution of the real world. I needs to be able to keep up with that and be able to adjust autonomously to changes in behavior across different assets over time and over location.
Mhm.
So our locally adapted world models, these adaptive technologies, in order for the AI to understand changes that are happening over longer periods of time and adjust to that, basically enables like a real-time or current picture, mental model of how these different systems are behaving. And on top of that, we also provide a language interface. So now this AI native, this machine native understanding of physical behavior can be translated and interacted with by a human through natural language. And that basically allows people to either query or prompt the model so they can ask natural language questions about certain things that they need insight about. And it also allows the model to be able to translate its understanding into language so that it can respond in a way that is interpretable to different people.
That's really helpful. I imagine that could be used almost any company that needs the physical AI's understanding.
Yeah, and I think that's exactly the promise of a foundation model and a
Hmm.
foundational approach to learning is that one solution can basically scale across all these different companies, these different physical environments, and these different assets without requiring a lot of per system or per machine engineering, which is really what has prevented scaling of operational intelligence in the past.
Wow. Can you give us a little peek into how you train these systems? Is it by just feeding it data, or does it watch humans first, or how does that all work?
Yeah, that's a really good question. So, a core part of our paradigm is that the model should be able to learn, so be trained on sensor data itself,
Okay.
so that humans don't have to go in and provide a lot of labeled data. They shouldn't have to inject equations of the physical laws as we understand them.
Right.
Basically, from sensor observations alone, the machine should be able to understand what these common underlying physical behaviors and dynamics actually are. And so we basically train by combining observations and sensor measurements across a very large, sparse but diverse set of different sensor modalities, different physical assets, different physical domains, and feed that all into one model so that the model is exposed to this extreme diversity of different
Hmm.
sensor observations, and from there be able to pull out what is actually common across all of them. So this provides the foundation model and the foundation mathematical space into which all of these different sensor measurements can be projected. And then from there, we enable this local adaptation where the machines basically use real-time local observations in order to adjust that for the particular machine that it's observing.
Wow. I am just so fascinated. I am learning so much about this physical AI industry. I just had no idea it was impactful on industries, on businesses, and it's very interesting to me. I know I keep saying interesting, but
Yeah, it was really surprising to me. We actually saw a stat pretty early in our company's history that about 85% of the global economy is actually based on physical industries.
wow.
But when we think about just the sheer scale of these sort of physical assets and physical systems and how much of our modern society is built on top of them, it really becomes clear, I think, the need to be able to scale human intelligence in
Yeah.
order to understand and operate and monitor all of these different systems.
And hopefully, if they are more optimized or they become more efficient because of AI's observations and suggestions, then maybe it would take less power to power it, or it would be a little more sustainable as well.
Exactly. Yeah. And I think that's exactly the potential and the promise and what we are striving for is that the modern systems, modern physical industries, there's a lot of room, I think, for optimization so that we can get to better environmental practices, better sustainability, as you said, better use of resources. And I think that really, to me, is one of the potential benefits of introducing physical AI at the scale that we're looking into.
That's really cool. And when you worked on the Soli radar at Google, that uses radar sensing for gesture and motion detection in consumer products. What did that experience teach you about moving advanced sensing technology from the lab into the real world?
Yeah, I think one of the things is, again, just the diversity of the world. So you might develop things in a lab, but you really need to make sure that they're robust to different areas in which they're deployed, different user behaviors. We noticed that with radar, it's even sensitive to things like the enclosure or materials around it.
Hmm,
So all of these things have to be taken into account in order to build a system that is actually robust to real world conditions.
nice.
And the other thing I think that our company really tries to emphasize and is a foundational component of our culture is that there needs to be a very tight, like intertwined development, both of the technology and the design. So
Mm,
thinking about the user experience, how people are actually going to interact with this technology, how they're going to use it, and is it in a way that actually is seamless and provides value to them, is something that I think needs to be considered from the inception of the technology. It can't
mhm.
be technology first and then design second. It's really a co-development.
Interesting. And I'm assuming if the sensors are outside or the machines are outside, weather could impact it. So the design is super important.
Exactly. And this is just speaking again to all these different environmental conditions and real world physical conditions that actually impact the way that technology behaves and that we need to take into account. And I think it's maybe worth mentioning that when we talk about world models, our models are really aimed at understanding these operational behaviors of these machines and these systems. A lot of world models in discourse today are aimed around predicting what comes next or
Mhm.
simulating the future. And so the problems that they're trying to solve, I think, are things like realistic spatial simulation. So you can create visually realistic worlds for gaming, or being able to train autonomous robots in order to affect a certain action. But the operational understanding that our world models are trying to build is really around what is the understanding of the current state of the system. Can we explain it? Can we understand how it got there? Can we understand what that means in terms of what is going to happen next? And the way that we refer to it is addressing this operational intelligence gap. And I think it distinguishes us a little bit in terms of what the world model that we're trying to build is actually going to do.
That's great. A lot of businesses today collect data already from machines and sensors and cameras and buildings and all kinds of other systems. But the people behind them may not always know what that data is telling them, especially in the real moments. So, where do you see physical AI creating the most practical value? Is it monitoring the operations, improving safety, catching problems earlier, maybe something else?
Yeah, I actually think the combination of all of those is what we're seeing in high demand from customers today. I
Yeah.
think the ability to monitor systems in real time to make sure that things are operating nominally, that they're not going past safe thresholds of behavior is very important in order to prevent downstream accidents or faults. So, this is one canonical use case that we're addressing with our product. Other canonical types of use cases are things like anomaly detection. So, can you identify when things are behaving abnormally that might be predictive of an eventual failure or a
Mhm.
fault? And then the third category, which you had mentioned, is around safety. So, the combination of these sort of sensor measurements along with human behavior. How do we ensure that human operators and humans in the vicinity of these machines are kept in a safe environment and not exposing themselves to any sort of risk or hazard?
That's great. I was thinking of even commercial HVAC companies. Their big old air conditioning, cooling units, and different things, they need sensors to know if their machines are running and things. Even that is a potential aspect, I would imagine, for.
That is actually a huge field and industry where we see a lot of interest.
Mhm.
And like 15-ish years ago, there was this big IoT explosion where we saw basically a lot of sensors being embedded into machinery and into the environment to be able to measure these sort of physical quantities of the real world. And so that sensing and that perception layer, the physical perception layer, already exists in the real world today. I think what we're seeing now is that the combination of large models and self-supervised learning and the commoditization of these sensors are all converging so that AI can actually be the common intelligence layer across all of these different things.
Yeah, that would just be so helpful. And like we mentioned earlier, a lot of people hear physical AI and immediately think about robots. But your work is showing that this category and what we've talked about is bigger than robots. It's
Mm,
understanding the signals coming from the real world around us.
right.
So, as the technology matures, what do you think will surprise people most about what becomes possible in the next few years with physical AI?
Yeah. To me, there's a couple of things. To me, what is most exciting and what will be most impactful is when physical AI can actually surface phenomena or insights that we didn't know already. So,
Mhm.
discovery of things that are new. And I think this is what is maybe most beautiful about operating in the physical world is that we can see it with our eyes, we can hear sound, but there's so much more beneath what we're directly perceiving.
Yeah.
And I think the ability for AI really to make sense of that and then expose it so that our own knowledge sphere becomes expanded could be really beautiful and exciting.
Yeah.
So I think, at least to me, this is what I would most look forward to in terms of practical changes that physical AI can bring about.
Yeah. And like you said, either the macro or the micro, where it's beyond our perception sometimes.
Exactly.
It is exciting to think about what could happen and what we could discover in just a couple of years with AI.
Yeah. And we see even more targeted data points of this happening already. For
Mm.
example, we worked with an energy company that operates a fleet of wind turbines, and they had on the order of 40 to 60 different sensors per turbine. And it's just this massive non biological type of sensors, and the ability to surface and discover from that when things are actually behaving abnormally. What are the commonalities in terms of normal operation of these turbines? It was pretty exciting because it was something that went beyond what we can actually tell just looking at the data traces themselves.
Yeah.
And I think that kind of points to what will become more and more prevalent, and also more just the scale of that will become more and more over time as we continue down this path.
I love that. And before we wrap up, I always love to ask when you do step away from your work, what are some activities or hobbies you're passionate about?
I have two young kids, so they
Mm.
take up a lot of time, and I really enjoy spending time with them, with my husband and my family. Yeah, I think AI has so much potential. I think it's really exciting from a science perspective and a technology perspective. But I also think it makes me value at least like the human interaction a lot too, and just to engage with people in that physical interaction and talk about things face to face and have that physical presence. Yeah, I just think it becomes more and more meaningful every day.
Oh, yeah, that's a good way of looking at that. I like that. Jamie, thank you so much for joining me today. I really appreciated how clearly you explained physical AI because it can get complicated and yet it is simple at the same time, but it's way more than robots. And I appreciate you sharing your insights about that today.
Thank you so much, Alicia. I had a great time. Really
Oh,
appreciate it.
good. Yeah. And for anyone who would like to learn more about Jamie's work in Archetype AI, you can visit archetypeai.io. Keeping you connected to tomorrow. Today, this is Alicia with AInews.com.